Hello everyone and welcome to Civo Crash Course. My name is Saiyam Pathak and I am a field CTO at Civo. So Civo is a cloud native service provider. It has a bunch of offerings and we have our own data centers, our own offerings. And in this particular whole course, what we'll be going through is each of the offering that is available, what you can do, how you can create and the CLI, Terraform, all this stuff that you can do with Civo in single comprehensive course. So without wasting any time, let's get started. So this is the first screen. When you go to civo.com, civo.com, you will be able to see this particular screen. So there are two things. If you are already a customer, then you can log in. If you are not a customer, then you can try Civo for 1 month with $250 free credit. And you can give your name, email, and password, and then verify, and then add your card. And then you should be in. So that's how you can create it. And you can see what is Civo. So Civo is a cloud native service provider. What we offer. So we offer a lot of services, and you can see in our products page, like the first one that we started off was with the compute and Kubernetes, and Kubernetes being our main offering. But over the years, what we have done is we have evolved according to the enterprises, and now you can see there are different sections. Now you have public cloud, where you have compute, Kubernetes, managed databases, load balancers, Civo Stack, enterprise for your own hardware that you get enterprise ready, HCI solution, and Kubernetes hosted at edge. And on the machine learning and AI side, we have expanded since 2023 was all about machine learning, and 2024 we even see more adoption. So Civo was, again, one of the first ones in getting those GPU capacities upfront and getting Kubeflow as a service, cloud GPUs, carbon neutral GPU. We got a partnership with Deep Green, which uses the server heat to heat up the swimming pools when you are running machine learning workloads on that. And one of our biggest customers is actually hosting their production offering on that, which is Fermion. So this is the gist of what we'll be talking about today. So what we'll do is, I already have an account, so I'll do login. And once you log in, this is your dashboard. So this is the Civo dashboard. So you can see your invoices. You can see this month what you can see the credit balance if you are having that. And these are the set of services which are there. There's the option to create teams as well. We might go through that later in the course, but first I want to cover all the offerings that will create an impact. Basically, for your application, why would you use Civo? First, let's start with regions. So Civo is having different regions, and what do we mean by different regions is that Civo is having its own data centers in these regions. So you can see in United States, we have a region in New York and Phoenix. In London, United Kingdom, we have in London, and then you have the Deep Green region. So Deep Green region is the same partnership, the carbon neutral region that is there. And then you have a region in Frankfurt, Germany as well. And yes, we are expanding. So in 2024, you will see a few more regions popping up in the region dashboard, providing you even more diverse choice of where you want to deploy your application. So that was about region. Now, this is the dashboard. So the first service that we'll be talking about is Kubernetes. So let's go to Kubernetes. And since we are in London, so we are in London and we have Kubernetes. Now, let's delete this cluster so that we can start empty slate. I want to point to github.com/Civo, and I want to show you some of the open source stuff which is there and some of the contributions that you can make and some of the other projects that you can use. So first, we'll be going through the UI for each service, and then we'll try to use some of the other automation tooling for this as well. So this is Kubernetes cluster. So it's saying, hi, Saiyam, let's get started, and just a basic Kubernetes definition. And whatever you can do, you can always do with Civo CLI. So Kubernetes, if you are not sure with what Kubernetes is, you can check out the complete playlist of the Kubernetes and Docker course on Civo YouTube channel itself. So there is extensive course developed by Civo team where you can learn all the concepts about Kubernetes. So Kubernetes in a nutshell is about deploying your containerized application. So let's say you have an application that you have written in Python and you have containerized that, and you can simply run and orchestrate that inside Kubernetes. And we, as cloud service provider, provide a managed Kubernetes offering on top of that. So that you don't have to create the clusters, you don't have to manage the cluster, you don't have to worry about the updates and all the other difficult things that you would otherwise do if you are self-hosting it. So that's what Kubernetes is. So if you have an application and you want to deploy it, you have like microservice application and you want to deploy it on Kubernetes, then by far the best choice right now is Civo Kubernetes. Yes, you can call me biased, but it is what it is. So let's try to create a cluster and we'll name it Civo Course. So this is the screen. You can stay on the single screen and create a Kubernetes cluster. How cool is that? I mean, that's really dope. So what you can do is you give a name, you give the number of nodes, you select the size. Now there are different size options and the pricing and all is pretty straightforward. So you can start with as small as a cluster of extra small size with 1 core CPU and 1 GB RAM, NVMe storage, and you can have data transfer rate. So data transfer is included. So there are like the ingress egress fees. That's what is included. So you don't get charged extra for that. And we'll go to the pricing page as well very soon. And then you have performance, like if you need some high performance nodes, so you can get those set of nodes with their per month costing as well. And you can switch here and get the per hour costing. And then you have CPU optimized, RAM optimized, and you have GPU nodes. So we'll go through some of the GPU nodes as well. So first what we'll try is, we'll try to create a medium node cluster because we actually want to try some basic application and see how it is running, then install some application. If you want to try out a lot of things, a reasonable is a medium size nodes that you can start with. So what it will do is, it should in theory create Civo Course Kubernetes cluster with 3 nodes with medium size, and there is a network. Now network is basically the firewalls and settings that you want to. So you can create a cluster in this particular network. What you can do is, you can actually go to our networking section and go to networks, and you can see our networks over there. So what we can also do, so there is a default network that will always be there for you if you do not create. If you want to create a new network, so we can create a new net. So that's a new network which is created. So a new network gets created. Now when you go here and you create a new cluster and we type Civo Course and we select medium, we can see a new network also appearing over here. So we can say a new network. Now you know that we have not created any firewall. So there is a default firewall over here. Also, if we do not want this, we can create a new firewall. And in this create a new firewall, there are predefined. So you can call Civo Kubernetes as an opinionated Kubernetes clusters because we want people, developers, enterprises to just start going and deploying their application without like hustling too much. Like it should be self-explanatory. So you can see there are specific ports which are required, like port 80 for non-encrypted, 443 for encrypted, open port 6443 for Kubernetes access, open port 6443 access from my IP only. So all these things are doable. Now what we'll do is, you can do any level of security over here. You can even deselect that and then, create anything inaccessible and then give only specific IPs, a specific access to specific ports. But for now, what we'll do is, we'll understand and open all ports, which you should not do. But this is like for the demonstration. So I want to show you, like, because I want the traffic to be flowing here and there. Or we can just simply go with the basic ones, which was pre-selected. That also works. Now in the CNI, so whenever you install a Kubernetes cluster, you need networking there. Now, Civo Kubernetes is based on 2 offerings. So Civo has 2 offerings in Kubernetes. So the first one that we started out was with Civo as a first ever cloud native service provider to provide first ever managed Kubernetes service based on K3s. So yeah, that was a long sentence, right? So K3s is a Kubernetes distribution. That is the only distribution which is a CNCF sandbox project. And K3s is a stripped down version that removes all the entry cloud providers, entry storage drivers, a very small binary size, running everything as a single process, providing a lot of things out of the box. So what we do is, we provide a managed Kubernetes based on K3s. We also recently launched Talos. So Talos is another OS built for Kubernetes. So built for Kubernetes from scratch. I mean, that's very huge. That's very big. I'm a huge fan of Sidero Labs, the creator of Talos, Andrew, one of my good friends over there, they have put a lot, and obviously their whole team has put in a lot of effort to build something which is very unique. So basically, in Talos Linux, it's all API based, it's all YAML based. There is no SSH. Now that's the huge part when it comes about security, because like we have seen in 2022, 2023 era, how much impact security has created. How much acceleration and how much people want their systems, their application to be deployed in a secured environment, and that's where Talos Linux come in. So these two are the Kubernetes offering, K3s and Talos Linux, and my recommendation is any, if you want really faster, like both are faster cluster launches, so you get a Kubernetes cluster in under 3 minutes. But I think if you want to go more into the security domain and if you want your clusters to be more secure, then go for Talos Linux. And for K3s, you have options to select CNI as well. So you can select Flannel or Cilium. Cilium in 2023 became a graduated project, and that makes sense because Cilium is a go-to choice when it comes about network policies and, advanced networking stuff. That's why we have an option where you can select Cilium as a CNI with K3s. Now, these are advanced options and these are optional, even if you do not choose anything. For the timing, what happens is, like if you just give a name and create a cluster, you can do that. What happens is it automatically do Flannel as a default CNI and K3s as a default cluster for now. You can also choose Kubernetes version. So what we'll do is we'll try to choose Kubernetes 1.28 version, and 1.29 is out, and K3s, I think, just recently launched their 1.29 version, which will soon be available as an experiment development version with Civo CLI. Now, next up is the marketplace. So Civo has a marketplace. Now, a marketplace is open source, and our marketplace is having more than 100 applications, and most of the applications are maintained by the maintainers. And if you are an open source project maintainer, you want to have your application listed on the marketplace, is pretty simple. You can raise a PR to this particular repository. So you have this, and what you can do is you can simply select the applications that you want to install. So there are different sections, like you want a database, you want storage, you want monitoring out of the box, like Prometheus Operator or Parka or Uptime Kuma, Weave Scope, Loki Stack, or you want CI/CD like Argo CD out of the box with the latest version 2.9.3, or you want a chaos engineering to be implemented, or you want a management app. In the management section, you want, Ghost, you want GitLab, you want Kubeflow, you want QBNB, Kubella. So there are like plenty of options over here that you can select. Now, by default, so what we have done is we wanted to remain as close to K3s as available. Now, K3s by default has metrics server and traffic installed. So what we also do is we install by default metrics server and traffic as node port, but it gives you you won't know that it's a node port service because the cluster URL that you get, it works out of the. So what we'll do is we'll keep the default applications because I want to show you without doing anything and just creating a new Civo Kubernetes cluster, you will be able to deploy an application, expose it as HTTPS, and get going. So let's create this cluster. So you can see the cluster is getting created, and you can also see the cluster is building and the nodes are starting to appear, and soon they will be created. So the cluster is created. You can see this is the cluster information. So let's go through that. The cluster is Civo cores. This is the Kubernetes version. This is the network that we created. And we can click here to download the kubeconfig file. And let's download that. And I'll show you what that means in a second. And then this is K3s cluster. And then this is the external endpoint for the cluster. And this is the DNS name for the cluster. Now we'll go through each and every step how to do that. What you can do after the cluster creation, you can create a pool. So what you can do, if you want, you can add a new node to this particular cluster. And this can be interesting because you can add a GPU node. You can actually add a GPU node for this particular cluster. So let's go back. We'll not add it right now. You can also upgrade and you can scale your node pool for how many number of nodes that you want. Let's go back. Now we have downloaded the kubeconfig file and we are ready to interact with the cluster. Now what we did, we simply added a name And although it was having a default firewall, we created our own new firewall and then did a bunch of things. But even that was not required. So you can see we have a Cilium as a CNI. We have a new cluster that got created and everything else is in place. Now let's go to the command line and try to interact with the Kubernetes cluster. So first step, the basic thing that you need is you need to have kubectl installed, because kubectl is the tool that is used to interact with the cluster. And then you have to expose the kubeconfig variable. So export kubeconfig user Saiyam downloads, and we'll see kubectl get. So you can see kubectl get nodes. The nodes are ready. You can see the Kubernetes version. So our cluster is up and running. Our nodes are there. Let's do kubectl get pods -a to get pods from all the namespaces. And you can see it has metric server, which is already there. I think we accidentally also clicked the Argo CD. So it installed all the Argo CD components, and it has traffic installed for the nodes, and it also has Cilium installed. So we have everything up and running. And for every job that gets done, you can see there is a job. For every marketplace application, there is a job where you can see the logs and stuff for further debugging. So what we can do like kubectl run nginx -image nginx. Now the thing is, what we want to do, we want to deploy an application. We just want to deploy an application. Now we got a cluster from Civo. So we got a cluster from Civo, and we are now trying to deploy an application. So let's do that. Let's do it in a very simple manner. So kubectl run nginx. It should be getting us the pod, kubectl get pods. And you can see we have nginx pod. So we got our nginx pod up and running. What we'll do is kubectl expose pod. And it created a service. So kubectl get svc. So what we are trying to do here is we are trying to create a Kubernetes service, because in order for anyone else to access your application, you need to expose your application as a Kubernetes service. So that's what we have done. So we have created a nginx service as well. But wait, this is a cluster IP service. Cluster IP service can only be accessed within the cluster and not outside the cluster. For that, either we have to create a node port service or a load balancer service. Load balancer obviously costs you extra. So do you want to create that? No, you have traffic installed. So traffic is a ingress controller. So an ingress controller is automatically installed for this particular cluster. We can actually create an ingress for this particular resource and then try to run this. So what we'll do is vi ingress.yaml, and we will copy the basic ingress example for Kubernetes documentation. But we don't have to add these annotations because we don't have to specify anything over here. We'll keep the default rule as / and backend service name is nginx. That's pretty much it. So you can see backend service name is nginx. Now what we have done here is we have done everything via an imperative way. You can also create YAML files and do everything. So everything is there in the Kubernetes course. Like if you want to learn about the YAML files, how to do that is it. This is a Civo specific course, like how you can use Civo to deploy your application, how you can interact with the clusters. That's what I'm, trying to show you over here. So in the ingress, let's do a cat of it, and let's see, you have an ingress, you have rules, you have /path, and service name is nginx, which is over here, and port is 80. Now that should be it. So we'll do kubectl apply -f ingress.yaml, and we can see our Kubernetes ingress is created. Kubectl get ing or ingress, and you can see we have the address. So what we can do is we'll try to curl, and we can see welcome to nginx. How cool is that? Now the thing is, if we try and we hit that in the browser, we will see it's not secure because obviously we didn't have any TLS over there. And we didn't specify any specific host name for that as well. So what we'll try now is we'll go a step ahead. We will try to add HTTPS. So now what we'll do is we'll try to add HTTPS for our application, which everyone should. Let's go to Marketplace. In Marketplace, we will install from the architecture cert manager. Cert Manager is a tool that can manage your certificates. So we'll install that, and we should see kubectl get pods very soon, a job appearing, and Cert Manager Cert Manager is already starting to appear over here. Cool. We should actually create a directory for Civo course and move our ingress as well to Civo course and then cd Civo course. Cool. Let's try to get everything in this directory itself so that I can commit that to GitHub and you have access to everything. Now, when you have to create certificates, so we'll create a few files now. So first will be certificate issuer.yaml. Now, this is a certificate issuer. Next is we want to create a certificate as well. So vi certificate, and here we have to give our host name. So what we'll do is we'll do nginx dot, and we are going to change the ingress as well, obviously. So nginx dot, and then we'll copy the DNS name from here. So we will copy the nginx DNS name, and everything is demo, secret name is demo, this is fine. And the next part is we have to change the ingress. So we will update our ingress. We need to add a few things. So I'll remove this. I will add this. And then I'll also again copy this for the host so that we have nginx dot. So what we are trying to do here is in the ingress, if we want HTTPS, we have to add the annotation cert manager cluster issuer. And then in the rules section, you have to define a host, like where this particular application is hosting. So this means when you hit this particular URL, you should be redirected to a backend name hello service. Now, in this case, our service name is nginx. And that should be on port 80. Now, if it is TLS, then what is your host? It is the same host with secret. So all these things should work well, and we will create one by one. So kubectl, first we'll do kubectl get pods -n cert manager just to see everything is up and running. Yes, everything is up and running. So kubectl apply -f dot. I think we need to apply all the files. So we will do that. Okay. We need to fix the namespace. We need everything in the same namespace. So let's not do this in demo, and let's apply again, because we have everything. We have the nginx server and the nginx service created in the default namespace. kubectl get pods. Obviously, there's no changes in the pod, so nginx pod is up and running. Kubectl get svc. We have the same service. Kubectl get certificate. We have the certificate, which is false. It might take some time to get on. Kubectl get ingress. And you can see we have a new ingress that got created because we haven't deleted the previous ingress. We can delete that. It's simple. Kubectl delete ingress. Now we should only be having the ingress, which is for HTTPS. So now we do kubectl get certificate. The certificate is true. Kubectl get ing. And we can see demo app ingress is already created. Now let's hit with HTTPS. So HTTPS and welcome to nginx. So we can click here. We can see that the connection is secure and certificate is valid. So that's how you can take your application from 0 to HTTPS with the cluster issuer, cert manager, ingress controller in place, certificate, and proper ingress created for your deployment resource. So that's what we did. I'll put all the resources in the GitHub repository. So you can see what we created was a cluster issuer, then a certificate, and an ingress.yaml for the deployment that we created. And the deployment and service were just a simple nginx pod and exposing it as a cluster IP service on a different port. So that's pretty much it from the Kubernetes side of things. I mean, there are a lot more stuff that you can do, obviously, with Kubernetes. It's endless how you can deploy your application, what all marketplace applications you can install, and then you can have monitoring on top of it. You can have, a number of different things. But from Civo's perspective, this is how you create the Kubernetes cluster. This is how you can install the application, and then you can use and create end-to-end HTTPS deployed application. And that will get out of the box. So you didn't install anything other than creating a basic cluster. So you can use the same DNS name and use it, and then add this as a CNAME or whatever you want in your own DNS, and that should point to your website. So like this is how you can do it. Now moving on to some of the advanced concepts, what we are going to do is, since we are on Kubernetes, I want to create a more advanced application. In this application, what we will try to do is we will try to create a database. So what we are going to do is we'll try to create a database. Before moving to that section, I want to show you some of the other things as well. So first, let's do kubectl get pods -a. Let's try to focus on a kube system namespace. So you can see there is a CSI controller pod. So we have a CSI controller pod and a CSI node. So that's what I wanted to show. Now what that means? So that means that if I do kubectl get HC, which means kubectl get storage class. So there is a Civo volume default storage class, which is already there. That means if you create a persistent volume claim, you should be able to get instant persistent volume, which is packed by our storage engine based on open source MyStore, and then that will be attached to this PVC, and you will get a highly reliable volume over there for your persistent application. So basically for your stateful workloads, you can use this particular thing. How to do that? Let's create a simple workload from Kubernetes documentation of PVC. So we'll go back, we'll do mkdir persistent volume, pd persistent volume, via pvc.yaml. So let's create the persistent volume. This is the persistent volume, and it's a read-write once, and we have requested the resource to be as a 3 gigs of memory, that 3 gigs that we need. So let's save it, kubectl create -f pvc. So the PVC gets created, and after that, what we need to do is we need to create a pod associated to that in order to use this PVC. So we'll do pod.yaml, and this is the pod, and we can see in the spec section, we have specified volumes. Now, in order to learn more about storage class, Kubernetes volumes and stuff like that, you can again go back to the course on Civo Academy, and you can check on Civo YouTube channel. But again, we have to focus on Civo services because this is Civo crash course. So we are focusing on that. But just I'm explaining like how you can use some of those things and what are they backed by. So if you create volume and you create a persistent volume claim, and we have given a claim name, and that's a simple container which is there. So kubectl apply -fpo. So we can see the pod is created. So get PV. So we should be having a PV pretty soon. And we are trying to check the PV, and we see in some time the persistent volume has been created. We should be able to see the pod also up and running. So we can see our task PV pod has gone into container creating state now, and the PVC should also be bound to that particular PV. You can see that this is in bound. So that's how you can use persistent volume claim in Civo Kubernetes, and you don't need to create a storage class as well. So basically you get everything out of the box. You don't need to have an ingress controller that is also there out of the box. You can use it for your applications. You get storage class out of the box. You can use it as application. You can also do kubectl run demo -- image equal to nginx, and then kubectl expose pod demo -- port 80 hyphen type, I think it is, load balancer. And we can see kubectl get svc. We should be having a service type load balancer with a pending IP. And we have our cloud controller manager also running on the cluster that should soon provide us, very soon actually, provide us with a external public IP. And if we go back, we go here, obviously we don't have any TLS and stuff, but it should give the results. That's how quick it is, right? That's how quick you get a public IP for your load balancer service with Civo Kubernetes. So that's how fast it is. Plus, you can check all the other things here as well. So if you go to volumes, so here you have a section of volumes. So volumes will tell you how many number of PVs and PVCs you are having. So you can see there have been an unattached PV of previous, but this one is Civo cores attached to Kubernetes cluster Civo cores. This is the persistent volume that we have created. And you can see this volume is currently being used. If I go to my Kubernetes cluster, we should also see the load balancer that we have just created. So in the Civo cores, you can see we have few sections that appear now. We have persistent volumes which appear now, and we have also the load balancer. And interesting thing is, in the load balancer, you can see the algorithm, you can see the action, you can actually view the load balancer, you can see the firewall attached to it, you can see the endpoints attached to it. So everything is something that you can see. Plus, you can also get the DNS name. So every load balancer will immediately get a DNS name if you want to use that as part of your ingress. So you can create a load balancer type of ingress controller and use that as a DNS name, and then use different ingresses for your different set of application or for L7 type of load balancing, like the app level type of load balancing. So that's how load balancing is there. And these are some of the stuff that you can do with Civo Kubernetes, and out of the box, you can create your persistent volume. So you get a Kubernetes cluster, you get persistent volume, you get a storage class out of the box, you get a load balancer creation out of the box that you can create. So service type load balancer also works. So because there is a cloud controller manager and there is a CSI driver for Civo, which also gets installed onto your cluster, and you do not get to see the control plane. So that's the fun part. You don't see and you don't pay for the control plane. So you don't pay for the control plane charges as well. You only see the number of nodes over here. So like we created a 3-node medium cluster, and that is what you see. So that is what you see. You have a 3-node Kubernetes cluster. There's nothing apart from that which you see. I mean, you should be able to pay only where your applications are being deployed. Let's quickly check the civo.com/pricing page, because this is what I wanted to show you. Like I have been saying, we have simple and predictable pricing because we have, and it's up to 75% less costly than the hyperscalers, which is a good stuff. And no surprises of egress fees, ingress fees, whatever that is. Billing model is created from the scratch. And you can see we have different services. For Kubernetes, you can see for different instance sizes, what is the monthly charge for single 1 gig, 30 GB NVMe, and all our storage is NVMe. That's why it is pretty fast. You can do the storage comparisons from our storage class and do the storage benchmarks using FIO with respect to the other storage class and other providers. And I actually did it. I have done it across almost all the providers, and R is one of the fastest in terms of the storage performance that we get on our storage drives. So that is something also which I would like to mention in this particular section, because we just talked about persistent volume. So this is like $5 a month, and then you can go to the hourly price as well, and same for the other. So you can see the volumes that we created. So if we create a 20 gigs or 1 gig of volume costs your $0.10 a month. That's how the volumes. And if you see the load balancer cost, you can see monthly cost of a load balancer comes out to be $10 a month. So that's a pretty transparent and fair pricing, which is there. And those are the data transfer costs as well. Like we provide generous data transfer. And if you need additional data transfer on top of the 1 TB, 2 TB, 3 TB, whatever that is provided, then that cost is also mentioned over there, which is 0.01. Yeah, 0.01 per gig. So that's all about the pricing, and you can check the NVIDIA GPU pricing as well. You can see the compute instance pricing as well. We'll talk about compute instance. We'll also try to create a compute instance using the CLI so that we can do all forms. We can try to see UI, CLI, and different stuff from where you can do the automation and stuff as well. And then in machine learning, you have Kubeflow as a service pricing as well. So if you create a small 3-node small instances cluster with 180 gigs, 18 gig transfer, you are paying $250 for that. So you are getting these pricing for Kubeflow as a service. So all in all, like whatever the pricing is, the pricing is simple, it's predictable, it's straightforward. It is what it is. It looks and the bill that you look is what you get. So that's it for Kubernetes. But wait, we were talking about databases. So let's finish the databases section as well. Like oftentimes we require to create a Kubernetes application that is backed by a database, and we need a database to be working. In Civo, you get an option to create managed databases as well. So there is a section of databases, and what you can do is you can create a new database. So what we are going to do here is you can create, as of now, 2 type of databases. You can create Postgres and MySQL. So we'll do demo course. So that's what we have created, a demo course MySQL database, and you can choose different network. So you can keep in the same network whatever you want. You can create a new firewall or choose any of the existing firewalls, and you can create any of the sizes which are there, like 2 gigs, 4 gigs, 8 gigs, 16 gigs, and then you can see the monthly hourly cost. You can also add additional nodes for this. So if you add like 2 nodes, you can do that. So that will be obviously additional cost for it. And that's pretty much it. So after this, you just hit on create database, and it should start creating the database. And very soon it should have a public IP, have a username, password, host, and port number. So that's the database creation. And then you can forget about database. If we see our products and we go to the database section, we can actually see you can launch all these, and Redis is coming very soon. And there's no additional fee for database access, data transfer, or extra IOPS, which is there. And you have the automated daily backups. So you can back up your database and transaction logs on a daily basis to ensure the data is well protected. So those are some of the stuff that you can see in the product section as well. Now it's now time everything gets ready. So you can see there is a username, root, there's a password, there's a host, and there's a port. So everything is up and done. We'll try to use the same Kubernetes cluster, and we will deploy a new application. So here I have a new type of application. Now this is a database type of application. Now how I can say that? So there is a app.py, and you can see here, it's a simple application that is, reading some of the secrets from we have to create a Kubernetes secret, and then we have to mount that inside the deployment, and then the Python code will be reading that from this particular location. So you can see it is reading from a path. We can specify the path, and then it strips it down, and then it tries to create a connection using the MySQL connector, and it creates a connection. After creating a connection, there are different methods like get, which is the select star from goals. So goals is a table that will create inside the database. And then you have post for adding insert into the goals table, and then you have remove, which is delete from goals, and that's what your application code looks like. The Docker file is simple as well. You're taking a Python 3.9 Slim image, installing the requirements.txt, and using the Gunicon server to serve the application. Pretty straightforward stuff over there. You have a deployment file. So deployment file is also simple. It's my app. It's for now one replica. Now you have a container. So I've already built this image. You can build it with your own image, or you can use the same one. And then you can, basically it's like everything is available in the Git repo. You can clone it. You can do some of your changes in the HTML, CSS and stuff. And then you can build it, and then you can push the image to your own repository and use that particular image over there. So basically you can do all these. And then there is a volume mount section. So here we are mounting etc. We are doing a volume mount of etc MySQL secret, read only true. And for the volumes, we are using a secret with the secret name MySQL secret. And this MySQL secret we will be creating, which has the information about the connection strings or connection settings for the database that we have just created on Civo dashboard. So that's how it is being done. And then you have this simple service.yaml. So service metadata selector, it is selecting this app. The port is 80 and the target port in the application is 8080. And then we have again same cluster issuer, certificate, and the ingress for the application. If you are wondering what is in the template, I can show you that. It's just the index.html. So that's a simple index.html with different color settings and stuff. When you see the application, you will be able to see how stuff works. Now let's try to do it step by step. So first thing before the deployment, because the deployment will fail because we haven't created the connection string as a secret. So we have to create a secret. And also we have to create the table inside the database. So we have a README. I have added the README as well. So we will edit the README according to the settings of what we are having here. So username is root. So we'll put root, which is fine. The password is this. It's okay if you can see the password because I will be removing this database anyways. And then we have a host. So this is the host. And then the DB name is goals database. So we have to create that database as well inside the Dbaas that we have created, the MySQL one. So I think that's pretty much it. We should be able to create this particular generic secret. So let's do that first. So MySQL secret is created. Now let's log into MySQL host and give the proper host, add or enter the password, and we are in. Now we'll be creating the database. So we have created a database. You can see create database goals database. That's what we have used over here. You can see that as the DB name. And the next is creating the goals table. So we have used goals database, create table goals, the goal name and ID over there. So our MySQL stuff should be done. We are, I think, in a good position to do the deployment of our deploy.yaml file. So let's do that. kubectl apply -f deploy. So the deployment looks created. Now what we'll do is kubectl apply -f service. The service is created. So after everything, what we have done is I have also created a certificate CI ingress. I have used the same ingress, just pointed it to a different service, and I have deleted the old ingress for the HTTPS application that we did, just to avoid, too many certificate requests that being going for one particular domain. So just to avoid that, I have done this. So what we are now left with is, if I do kubectl get ingress, we have an ingress which is kind of the same, but now it actually points to the service that we just created for this app, which is kubectl get svc my app service that we just created a few minutes ago. So let's go to the same URL that we went before, but this time it should give you your goals 2024. Now, very interestingly, here we will also try to get into the database because that's what is important for now. We want to get inside the database and check if things are getting in or not. So we are now in the database and we will just use the goals database and we'll do select star from goals. So we can see it's an empty set. There is nothing as of now. And we have your goals for 2024. So like, let's say your goal is to live or to eat, whatever that is. So we can just do an add goal and to live, to be healthy, to learn tech. So we added 4 goals. Now it also has a delete. Okay. So we added 4 goals. So what we'll do is we'll do a select star from goals and hooray, we have our 4 goals in the MySQL database, which we actually created demo codes in the database's Dbaas offering of Civo. So that is the Civo Dbaas offering and how you can use the Civo Dbaas offering with your Civo Kubernetes offering and connect those. Because yes, very often you do need a database that you need to connect to, and that database also should be pretty much stable, and that's what it is. So that's a Cloud DB managed database that is provided by Civo. And let's say you want to delete something, it gets deleted. And if we do again, we'll see 2 rows getting deleted and we only have 2 rows left. So that's the power I wanted to show with a very simple application. I'm not a fancy UI expert, but yeah, the application works. It is connected to a database. It is deleting from a database and it is getting from the database as well. So everything is working in sync over there, and it is connecting Civo Kubernetes pod running inside Civo Kubernetes cluster to the database, managed database running inside your Civo account. So that's what it is doing. So till now, what we have covered is we have covered Kubernetes, we have covered load balancers in Kubernetes, we have covered the persistent volume claim in Kubernetes. We have also covered a HTTPS application of nginx, how you can expose that, and marketplace application, how you can install that. And also now we have covered the databases section where you have your own database Dbaas and how you can create a pod running on the cluster and then again exposing it as HTTPS with your specific ingress and stuff like that. So I think that's pretty much it from the Kubernetes volume in the database perspective. For the compute, what I am going to show is, yes, you can create your compute instances as well. This is how it looks like from the UI. So you have GPUs or you have standardized. So you can create GPUs, and GPUs are NVIDIA A100s. So you can use those again with transparent pricing. And then you have standard compute instances that you can launch with flavors of Ubuntu, Debian, and Rocky Linux. You have a root OS default, and Civo as a user. You can see a super user and stuff. You can create none or a public IP address. Again, firewalling remains the same. You can choose existing firewall or existing network, or give a new network, create a new firewall, and then do that. And then SSH key, you can create your own SSH key and or select a random password. And you can also specify the installation script that is there. So what we'll do is we'll try to do that from the CLI. Now, Civo CLI. So we have a Civo CLI as well in our GitHub repository. And the CLI is a command line interface. So anything that you can do with the UI, you should be able to do with the CLI as well. So you can see it's pretty simple, and you can do brew install or just a curl, and it should install on whatever operating system that you are in. If you are a Windows user, then you can use Chocolatey Package Manager to install Civo CLI. So now let's do that. I think let's exit this. So I think I already have the Civo CLI. So what we'll do is Civo, and there's a new version available. So we'll do a Civo update. So we'll do Civo update so that we are on the latest CLI version over here. And we are updated to v1070. Let's clear out the screen. And if I just do Civo, we can see the list of things that it can do. So we can create our API key. So yes, first is we actually need the API key to interact with the Civo account. So how you can do that? So the first thing is you can go to your settings. In the settings, you can go to your profile. In the profile, you have your security. In the security section, you have your Civo API keys. So now since I have a team and I have different kind of teams over here, and I can regenerate that, I can copy that, and I can use it. And in this, you have like Civo API key. So what you do, the first step would be Civo API key. We can see we can add. We can see the current one, ls, remove, save, and show. So you can save a new API key, and you can add, you can remove, and you can show as well. Civo API key ls. And we can see I have different API keys. My current API key is set to Saiyam over here. So that's what it shows. We can also do Civo region ls. It shows which particular region my current Civo CLI is set to. We can also do Civo region use London 1. So we have now switched the region to London 1. So that's how we have done. So now it's London 1, and you can see this is the current region. So after setting the API key, and after setting the region, you should be able to create all the things like the network, the database, the firewall, instance. So this is what we'll be creating. You can also create reserved IPs, so you can have a reserved IP created as well for your instance. So let's create an instance. The command is pretty simple: Civo instance create. We provide a host name, we give a size, and we give a disk image, and we give initial user as demo user. And it should start creating an instance in Phoenix 1 region, which we will be also able to see in the UI happening. So you can go back. We have switched the regions to Phoenix 1. I will just refresh this, and we should be seeing a Civo course instance being created. So, and also the public IP already attached to it. So you can also get disk image sizes. So what you can do is Civo disk image ls. Yeah, so you can see the disk images which are available. Like, you have Ubuntu Focal that you can use, or Rocky, or Debian. So these are the ones that you should be able to use. So that's where I got this size from, the disk image. And you can also see the sizes. So if we go Civo, and we can see size over here, details of Civo instance sizes. So we can see Civo size ls. So this shows you different size available and what tag you have to actually use. So for extra small, or for whatever performance, or these are the simple ones. For G3 extra small, I think this is what we used. G3 small or extra small, something like that we used. Yeah, G3 small. So we have used G3 small. So these are the type instance. So you can use only the ones which are there in the type instance, and this specifies CPUs and the RAM. From here you can select which instance you want to create, and you can copy the size for that. So the name here will be the size in the Civo instance create command. And you can see how quickly the instance is created, and it should have given us a lot of information when we go inside it. So it will give some of the performance stats like CPU usage, memory usage, storage usage. It will also give SSH information for demo user with initial password. We can also upgrade this. We have a private IP, we have a public IP, and we can also assign a reserved IP to this. We can choose this particular IP. I already have a previous reserved IP, or we can create a reserved IP, and reserved IP costs $3 a month. We can also get the password for the instance using the CLI. So Civo instance password, give me the password of the Civo course instance that we just created, and we are custom. Like if we don't specify this, it obviously gives some more information. We just wanted to print the password, so we have printed that particular password. Now that we have the password, what we can do is we can SSH with demo user and the public IP, and we are into the instance. So that's pretty much it about the compute as well. The next part that we will go into is the object store. So we'll go inside the object store, and you can see object store is, saving the unstructured data. It's similar to S3, and is S3 compatible as well. So you can see you can interact with S3 API of the object store itself. So it's S3 compatible. First, we will create a new credential. So credential will be, let's say, Civo, or maybe just the course. So that's the credential that we have created. And we can get the access ID and the secret key. What we'll do is, there is a tool called S3 CMD that you can use to interact with the object store. So we'll use that. Or you can use the UI itself, but I'll use like the command line just for fun. So S3CMD -- configure, and we have the access key. We'll show details. I'll delete it anyways afterwards. So this is the access key. This is the secret key. Region is, let's see the region. Region is London 1. So we'll just leave it the same. So the object store name becomes object store .lon1, the region .civo.com. So wherever, in whichever application, like maybe you are installing any observability tool and you want to point the the storage to object store, and it is asking for a URL. So URL for Civo object stores are in the form of objectstore.region.civo.com. We'll leave that, and we'll leave rest of the things as it is, and it should probably be able to test the connections, and we can see success. Your access key has worked fine. Now what we will do is we'll go back and we'll actually create an object store. So let's create object store called course, and let me choose the credential course. And so that's the cost. So 500 gigs of store is $5 a month. That's how it is. So we create the store, and the store is created, and this is the URL for the course which is there. So I have object store repository. I have just a sample file over here. We'll try to put this sample file in the repository in the object store. So we'll use s3cmd put app.py to my file.py in the demo. So it actually mimics the folder structure over there. So let's see if it's getting done. Yes, it's getting done. And now we can check s3cmd ls s3 course, which is the bucket name, and you can see it's already present. Now, actually, the file present over here, the app.py, is not just a file. It is the actual sample code that uses subprocess to run a shell command. So I have written like all the commands that I just shown. Some of them I have already written. So this will upload a file. So this will upload a demo.txt file to this particular location, and then it will list the file in this particular location just like we did. And then it will download that file to a particular location on my system, and then it will delete the file. So first, let's see if the file is already there, because I have ran it a few times. Yes, it's there. We'll remove this, and now we do not have this file. Okay. So now let's run. Let's clear the screen first. Python app.py, and we can see the upload is done, and you can see there was a directory. Like in the directory, we added something, and then this is the file, the demo.txt, downloaded the file to this particular location and deleted the file from S3, our course bucket, using the S3 compatible, using the S3 cmd command. Now we can actually see the file should appear over here as well. So that's how we can use S3 cmd or similar tooling to interact with the bucket, use that in the code, however we want to use it. There are a lot of other libraries as well which you can use if you want to interact, but this is how you can do it. You can also use Civo CLI. So Civo CLI has like Civo Object Store. So we can see Civo Object Store, and now we can have a show or ls, like we can show the course, and it should give you the object store ID, the name, the access key, and the secret key. You will get the secret key using this particular command. So it will give you all the information, the size and stuff. But what if you want to get like how much objects are there, how many objects are there, what is the size, and all the other stuff? Because when you go here, like when you click the UI and you go inside the object store, you will be able to see like there is a folder structure kind of thing, and it has like my file.py. But what if we want to have total size is there, what is the size remaining, and things like that, so that beforehand if you want to update the bucket to a newer size. So there is a API for that. I have put that in the README. So you can simply do a curl command. This particular curl command is you are passing your API key. So I have already exported API key. So I have done like export API key and given the API key so that you not see the API key. And then https api.civo.com/v2/object stores, and then the ID. So we just got the ID from Civo CLI, Civo Object Store, show the course, the bucket name which is there, and it gives you the object store ID and stats. And in that, we'll get size utilized, max KB, which is the maximum size and the number of objects. With this, you will be able to get, and then you can go and you can, back to object store, and you should be able to update the store with size. So That's pretty much it about the object stores, which is there. Very simple, nothing very fancy over here. Next up is the machine learning. So in our ML offering, which is Civo ML, Civo Machine Learning, we have a few things. We have NVIDIA GPUs. So we have NVIDIA A100s, and you can launch a GPU with a compute instance. So you can directly go from here. And I did show you the screen when I was at compute. You can also launch a GPU cluster with GPU nodes. So you can have a Kubernetes cluster and you can have this GPU nodes. So you can do that. And what I want to show you is the KFAS offering. So in KFAS, you have Kubeflow as a service. So that means you get Kubeflow dashboard out of the box. You don't have to worry about creating a cluster or doing whatever and then installing Kubeflow, going through all the hassles, getting HTTPS out of the box, getting the authorization configured so that you can, authenticate using your Civo credentials itself. So everything is set up for you with the best practices in place, and you get out of the box Kubeflow dashboard with which you can create your Jupyter notebooks, RStudio notebooks, install whatever stuff you want. And it's super simple for the machine learning and the data science engineers to build, launch, and scale your machine learning projects or AI stuff that you want to do, which have been a hot topic for 2023, and it will even grow bigger in 2024. So you will be able to launch a KFAS cluster. And it's very simple because you don't have to do anything. So you just give a name, for example, Civo course, and select the size, small size, medium, large, extra large, whatever you want. And then you can, select a network, new net or default network, or create a new firewall, choose from existing firewall, all the same things. Like that's it. You don't have to do anything else. That will give you a simple KFAS cluster, and then you can just hit create. And you can see it has started creating the cluster, and it's very soon we will be getting a dashboard URL over here with which you can log in using your same Civo credentials used to log in for this particular account. So let's wait for a few minutes till the cluster gets ready. Okay, so the cluster is ready, and we go inside, and we can see we have a dashboard URL. We go to that particular URL. I have already authenticated with my credentials, so it says welcome to Kubeflow, which is powered by Civo. So we can start the setup. We can select a namespace. That's pretty much it. We can finish it. And it should give me a very cool dashboard. So what we can do is we have notebooks over here. We have tensor boards. We have volumes. We have AutoML, experimental. We have pipelines that we can run. So let's try to create a simple Jupyter notebook to see how we can start our machine learning journey with Kubeflow. So let's click on new notebook, Jupyter one, Civo course, and give it a RAM, like however much RAM you want to give, maximum number of CPUs, maximum number of, memory that we need, and then GPUs, volume, workspace volume, and let's launch it. So it will launch over here. So once the notebook is ready, you can actually connect to that particular notebook. I also created another demo notebook from a custom image. So you can actually create a notebook from a custom image as well. And then you can connect to those Jupyter Lab notebooks, and it will give you the environment. You can have your terminal. You can create a folder. You can upload from local. So all these things are available. And then you can also have your Git clone. So you can go to the terminal, Git clone the repository, and then start your model training and deployment on Kubeflow. You can this can be backed by object store. For example, you are going to tensor board. You are creating a new tensor board. You can have a PVC that you can create, and you can also mount a path, and you can create that. You can use object store. You can create that. And these are the volumes. So here you will be seeing the persistent volumes for particular notebooks which are there with the read write mode. And then you have your AutoML if you want to create a new AutoML experiment, random experiment, and start doing that. And then there is pipelines, all these stuff which you can take. So this is Kubeflow. Kubeflow is endless. There are a couple of blogs on Kubesimplify if you want to learn about Kubeflow, which are like Kubeflow part 1, part 2, part 3, that gives you a lot of in-depth info about Kubeflow, what it is, what it means, and stuff like that, with some more complex examples. You can also refer to Civo documentation for this. So now we have covered machine learning and stuff. There is one thing which we haven't covered is the platform. This is an alpha feature, so this is not something which is available, which is GA. This is alpha. So if you want access to platform, you need the flag enabled for your particular account to get this seen on your dashboard. It actually just is a pass, if I would say it in simpler terms. So you have your GitHub URL, and from there you can go to application deployed and get a URL and get working with it. Another cool thing that we have been working on, which very soon will be available, is called the Recite. So Recite is a transcribe audio using a machine learning platform. It is a whisper model, and you can just choose a file, transcribe the audio, and it should give you the audio results. Very soon it will be available in your dedicated platform where you will be able to see Recite, and then you should be able to upload them and then get them transcribed and then download from the UI itself. So in this crash course, we have covered majority of Kubernetes services. We used the UI, we used the CLI, but wait, I want to show you one more thing. So Civo also has, if we go to Civo GitHub, so if we go here, we have a Terraform Civo provider. So we have a Terraform Civo provider, which is there, and you can actually do everything with the Terraform as well. So let's do that. What is Terraform? Terraform is an infrastructure as a code tool, and you can use Terraform to spin up the infrastructure. So what we are going to do is we'll go into Terraform repository. So I have created, everything is available on GitHub. So you can actually go to Terraform provider Civo, and we have in the Terraform registry. So you can see everything from here, how to use this particular provider. So you need to have Civo version, and you need to provide the configuration and token and stuff. Main is the token. So that's pretty much it that you would want to do. And then is the documentation. So you can also see all the resources that are there, like how to create a firewall, how to create an instance, how to create a Kubernetes cluster. For a Kubernetes cluster, what all things are required. So you have to have a firewall. So before that, you will be creating a firewall. You will be creating a firewall rule. Then you will be creating a cluster, and you can also have, you can create a cluster with K3s if you want to define Talos. So you will be defining cluster type. So these are some of the things. So here we have segregated things. So we have Civo firewall. So if we see Civo firewall cluster, so this is the Civo firewall. So we are giving a Civo firewall over here, and we are getting the cluster name prefix from the variables. That's pretty much it for the firewall. We have a firewall ingress, and you can see it allows 8443 as the rules. So these are the ingress rules which are there. We have provider. So here we have like Helm, because we are doing a Helm install. We have Kubernetes because we are creating a Kubernetes object. We have Civo, and we are taking the Civo token. These are the providers. These are the configuration for Civo provider and others. So that's the provider. Provider is important. And before anything, we would do Terraform init. So it will check, make sure everything is working fine. And then main thing is, let's go through all the files, obviously. So this is the cluster. You can see a resource, Civo Kubernetes cluster, and we need to specify name, we need to specify firewall ID, we need to specify pool. In that, we have a node count, how much node, what is the node size, and that's pretty much it. And then we are using a resource called local file to save the kubeconfig file. So we are getting content is Civo Kubernetes cluster from here, and get the kubeconfig file and save it in current path kubeconfig variable. So with the correct set of permissions. Then you have a Helm ingress. So if you see, we are actually installing traffic. That's for Helm. And we also have a Kubernetes deployment, just to have an nginx deployment over here. So you can see it's a simple nginx deployment with replicas, spec, and all that fancy things. And the last thing is Terraform TF-vars. So what you have to do is just clone the repository. In the Terraform TF-vars, there is a thing called Civo token, and that's pretty much it that you have to give for Civo. And another thing is IO. And here you have all the variables. So you can see Civo token region, so is FRA, and it is having a cluster name. So the default is TF template, and then it gives that's the number of nodes, size, and all the other fancy things which are there. So when we do Terraform apply, it will check all the files and it will say 6 to add. So what it is doing, let's check. Let's go here. Yeah. So from here, it is adding a resource called firewall, and it is having ingress rules. So you can see the ingress rules of 80 and 443. It is creating a Kubernetes cluster. So resource Kubernetes cluster, and then a Helm traffic ingress, and then Kubernetes deployment. And this we'll know after the deployment. And you can see the spec section, all the things mentioned over here. And then is the local file for getting the kubeconfig as well. So what we are going to do is we will say yes, and it will start creating all the stuff which is there. So things are getting completed, and very soon everything will be ready, and we'll skip the creation part till the cluster and everything gets ready. So after a few minutes, you can see everything is completed. So you can, I'll just select so that it's visible. So you can see that the cluster was ready in under 2 minutes, which is so dope. So you got a cluster created under 2 minutes. And you also got local file having the kubeconfig from that particular cluster. You also have a Kubernetes deployment, as you can see over here, and everything is there. So let's see, ls, we should have a kubeconfig file. So export kubeconfig is equal to this, kubectl get. And we should be having a Kubernetes cluster, which is that K3STF template, which we created. If we go to the UI, we can go here and we can see in the FRA region that we specified, there is a TF template cluster, which is up and running. And we can also see kubectl get pods. We should be having the deployment that we created. And yes, it is there. So the main purpose of showing this was that we have a Terraform provider with which you can create all the resources. And not only Kubernetes, you can create your firewall, instance, object store, get the credential, have a reserved IP, volumes, all the things which are there. And these are the data sources for that. So you can go through the data source list as well. Everything is there in the documentation. This is the latest version. This is how you use the Terraform provider. So that marks the end of the course. And I'm so happy and glad that you came this far and you have learned all the services provided by Civo. So Civo is a cloud provider which provides managed Kubernetes based on K3s and Talos. And we have seen how to create a Kubernetes cluster, how to deploy a nginx application, and then expose it as HTTPS using ingress controller and certificate manager. We also have done a next level of example where we have created Dbaas offering. So Civo has a Dbaas offering, and right now we have MySQL and Postgres. That is coming very soon. So we created a MySQL database as a service from Civo, and then created a pod inside a Kubernetes cluster that consumes and connects to that database and do addition, deletion, and getting from the database. Next, we also did the object store. So we created the object store, created the credential, accessed the object store using the S3CMD command line tool. We also saw Civo CLI and created a compute instance using the Civo CLI and connected to that. We also saw in Kubernetes how to create load balancers, volumes, persistent volumes, and other stuffs. Then we moved on to the machine learning where we created a KFAS instance and we saw how to create a Jupyter notebook. There is also GPU NVIDIA A100 offering that you can use. And there's a deep green carbon neutral region that you can also use. We also created a network, custom firewalls, and you can add, remove your ports from where you want to give access to which particular IP. You can do that. So all these things we have covered in this particular course, and also some of the alpha things which will soon be in beta, and then GA is the platform thing and the Civo Recite. So apart from this, we do Civo Navigate. So Civo Navigate is a technical conference that we do twice a year, and the next conference is in Austin in February. Very excited to be there. Make sure to grab the tickets if you have it already. Check out Civo Navigate, check out Civo, sign up for Civo and get a $250 credit to try things out, all the stuff that we have discussed in this particular small crash course. And thank you so much for watching. Make sure to subscribe to our YouTube channel and go through Civo Academy and other videos to get in-depth knowledge of Kubernetes and other technologies.